Good afternoon and all. We are almost through with our paper. We are at the final chapter of this particular paper, block 4, that is time series analysis. What do we mean by time series exactly? What all we will be learning through this specific session is that this will we will be able to know what exactly we mean by time series, what is time series analysis, why should we do this, and what are the specific components of this time series, identifying the components, understanding how can we decompose the methods, or you may say understand the decomposition methods, then we will be computing certain seasonal reduces, and we will understand what exactly we mean by autocorrelation, and we'll be explaining the Box Jenkinson models and how this analysis will enable us in forecasting the future values using this historical data or time series data. So here we go. So what exactly we mean by time series analysis and forecasting? This is to understand how your data changes over time. So time series analysis and forecasting are used, which help track your past patterns and predict the future values. It is widely used in finance, weather, sales, and sensor data. It basically focuses on data collected at regular time intervals. That is, suppose say the sales figures of a specific company during the last 10 years. That is your time series data. So it basically your time series analysis basically focuses on such type of data. And it helps in identifying the trends, the seasonality, and the random changes that happen in your time series or in your data. So it is this analysis is basically useful for planning, prediction, and decision making of the future plans of a company. And the common methods that include your ARIMA, exponential smoothing, and machine learning models. So your time series analysis are commonly visualized using your line plot with time on your x-axis and observed values on your y-axis. This visualization helps in identifying the trends, fluctuations, and the underlying patterns in your data. So, time series analysis studies your data points collected over time that we have specified in our previous discussion. So, to identify the patterns, trends, and seasonal effects, enabling forecasting and informed decision making. So, we are speaking about time series analysis, time series analysis. So, what exactly we mean by time series? Time series is a sequence of data points recorded at a regular intervals, such as maybe hours, maybe days, maybe months, or years. So, unlike your cross-sectional data, which captures observations at a single point in time, your time series data is inherently chronological, making time a crucial dimension for analysis. So, each observation often depends on previous values, which allows analysts to detect trends, cycles, and seasonal patterns in the data. So this analysis is basically critical or crucial for making informed predictions. So basing on the previous, or you may say chronological data that we have collected over a several time dimensions, we will be in a position to predict and make the decision across various industries, including business, finance, economics, environmental science, and healthcare. So, what is your time series analysis? Understanding data through time. So, your time series analysis is a statistical technique used to analyze observations recorded sequentially over a time in order to identify the patterns, understand past behavior, and forecast future values. So, a time series consists of data collected at regular intervals, such as hourly, monthly, quarterly, or annually. The example of time series data may be your monthly sales or revenues. Time interval over here is month. Stock prices, that is daily. GDP growth, we calculate on the basis of quarterly, or we record on the basis of a quarter. Rainfall, annual. Electricity consumption, hourly. On the basis of that, we do something. And inflation rate, it is monthly. So, objectives of our time series analysis is basically identifying the long-term trends, detect the seasonal patterns. By seasonal, I mean maybe festive seasons, maybe your say the marriage seasons, and so on and so forth. Understand cyclical fluctuations, measure random variations, forecast future values, and support managerial decision making. These are the objectives for which your time series analysis is being done. So, conceptual framework, what we do? We basically collect our historical data, then we try to identify the pattern inherent in it. Then, on the basis of that pattern identification, we will be performing our time series analysis. And your time series analysis consists of three components. One is trend, one is seasonality, and one is cycles. And based on that, after making that analysis, we will be making the forecasting, and based on that, we will be taking the managerial decisions at our company level. So, what should be our strategy for making the production for the future year, and so on. So, step by step breakdown on the basis of that flowchart. First one is your historical data. The process begins with collecting the past data, maybe your sales figures, maybe basing on your problem, you will be collecting your data, and this serves as the foundation for your subsequent analysis. The next step in this particular analysis is pattern identification, that is, analyze historical data to detect recurring behaviors, anomalies, sudden shifts, or stable trends. This helps in understanding what has happened and recognizing meaningful signals versus random noise. So, what exactly is the pattern, and what may be the reasons for the behavior of the variation of the pattern that can be identified in this particular stage. The next is your time series analysis. Apply your statistical techniques to model the data over time, and this step formally structures the data into a time dependent framework, preparing it for decomposition. Okay. The next is trend, seasonality, and cycles. So, break your time series into its core components. Trend, that is long term upward or downward movement, that is, you observe the trend of your data. Then seasonality, regular fixed period patterns, maybe ice cream sales rising during every summer, that is your seasonality pattern. The cycles, longer irregular fluctuations, that is your economic boom or recession waves. So, next is your stages forecasting. Once you made this analysis, once you have decomposed your components, then once you have broken your series into its core components, you can be in a position to forecast by using the decomposed components, generate predictions about future values, and this could involve models like your ARIMA, exponential smoothing, deep learning approaches, and so on. And this some of these techniques we will be using in the work while we will be discussing during this particular session. Okay. The next is once you have done your analysis, then you will be in a position to decide about the things that you have analyzed. So finally, the forecast informed real world business actions such as adjusting inventory levels, setting pricing strategies, allocating your marketing budgets, planning workforce capacity. Based on analysis, you can be able to perform these sort of decisions. So what exactly we are doing? We are taking the data, we are finding out its insights, then we will be predicting, and on the basis of the prediction, we are taking the actions. So this pipeline transforms your raw historical data into actionable intelligence, enable managers to make informed, proactive decisions rather than reactive guesswork. So what is its relevance in business organizations? So these are basically used, or you may say the time series analysis is being used in business organizations for sales. Suppose sales forecasting, inventory planning, production scheduling, financial forecasting, energy demand forecasting, economic planning, so on and so forth. So key insight over here is that your time series analysis transforms historical data into future business intelligence by uncovering patterns hidden in time. So unlike your cross-sectional data, time series data preserve the sequence of observations. This sequence helps managers to understand trends, seasonal effects, and future business opportunities. Consequently, your time series analysis is one of the most widely used tools in forecasting and strategic planning. So, the analysis, why do organizations need time series analysis? So, in today's dynamic business environment, managers must make decisions about future based on information from the past. Your time series analysis helps identify patterns, trends, and recurring movements in historical data, enabling organizations to forecast future events more accurately. So key reasons for using your time series analysis is forecasting future values, that is predicting future sales, demands, forecast profits and prices, estimate future market conditions and business opportunities. For example, forecasting next quarter's sales revenue. It is also used for identifying long-term trends, determine whether your variable is increasing, decreasing, remaining stable over time, support strategic planning and growth decisions. So it is basically, you may say the example may be the growth trend in e-commerce sales over the last decade. And it can also be used for detecting your seasonal patterns, identify recurring fluctuations that occur at regular intervals. For example, festival season, retail sales, summer demand for air conditioners, holiday tourism demand, and so on. And it is also being used to understand the business cycles, analyze cyclical movements associated with your economic expansions and recessions. It helps organizations prepare for changing economic conditions. For example, automobile industry sales during economic boom and slowdowns. It is also being used for improving operational planning, that is optimizing your inventory levels, schedule production efficiently, allocate manpower and resources effectively. For example, forecasting monthly demand to avoid stockouts and excess inventory. Supporting financial decision making, It forecasts your cash flows. It forecasts on the basis of your forecast of profits. It forecasts your stock prices and interest rates, which enables you in improving budgeting and investment planning. So forecasting quarterly cash requirement. On the basis of this, you can be in a position to allocate and reallocate all your resources to the specific demand. So time series components, that is understanding the building blocks of your time series data. A time series is rarely a random collection of observations. So most business and economic data contain four fundamental components that together explain the behavior of the series over time. So basically, the components of a time series, that is observed time series, it consists of four components. One is your trend, and we designate it with capital T. One is your seasonal, we designate it with capital S. One is your cyclical, and we designate it with capital C. And random, we denote it with capital R. And generally, we express our time series components or the entire series with one as an additive model or a multiplicative model. That is, if your time series is YT, then it may be equal to the trend plus seasonal component, trend component plus seasonal component plus cyclical component plus your random component. That is one additive model, or else it may be your multiplication of four models, four components. So components of a time series that we have said, the four building blocks of the time series. One is your trend, that is long upward or downward movement. Example, maybe your growth in sales. The second one, maybe your seasonal, that is regular and predictable patterns that repeat over a fixed period. You may say your festival or holiday sales. One is your random, that is irregular, unpredictable and non-systematic variations, maybe during some pandemic, natural disaster or policy shocks. And policy shocks, for example, very recently your government has revised your GST on each and every product. On the basis of that, the sales of certain products, they risen like nothing. So that may be one of the example of your random component. The cyclical, you may say long-term fluctuations around the trend line due to your business cycles. That is, that as we have expressed, is your economic and the economic boom and recession. Just a minute. Okay, thank you. So every key insight into it is that every observed time series is a combination of these four components: trend, seasonal, cyclical and random components. And understanding these components enables managers to analyze patterns accurately and develop reliable forecasts. So, going in detail and understanding each and every component with a greater detail, suppose a trend component, your trend represents the long-term prediction movement in a time series. So, characteristics of it is that persistent movement over time, may be increasing, decreasing or stable movement, and it reflects fundamental growth or decline. Okay, example, maybe your growth in e-commerce sales, increase in population, rise in GDP, rise or growth, or you may say decline of your GDP over decades. So business significance is it helps managers to understand long-term growth prospects and formulate strategic plans. Number two is your seasonal component. By seasonal variation, it refers to fluctuations that occur at regular intervals within a year. Characteristics, repetitive pattern occurs maybe monthly, quarterly, or annually. It may be influenced by climate, festivals, holidays, and customs. Examples, air conditioned sell increase during summer, retail sales peak during festivals, tourism demands rises during your holidays, and so on. And business significance, it supports your inventory planning, staffing, and promotional campaigns. Depending on that, you can schedule these things. And third one is your cyclical component. As we said, your cyclical variation refers to long-term oscillations associated with business and economic cycles. Your business cycle phases are four. One is expansion, one is peak, one is recession, and one is recovery. So by expansion, we mean the economy is growing, GDP increases, employment rises, consumer spending is strong, and businesses invest more and production increases. Peak period is the economy reaches its highest point of growth, maximum output and employment, inflationary pressure often build up here, and this marks the end of expansion and start of a downturn. Then it is recession, economic activity begins to decline, GDP falls, unemployment rises, consumer confidence drops. So your business reduces production and investment, typically lasts at least 2 consecutive quarters. So during that period, you will be planning something, doing something, and then you will be recovering. So the economy bounces back, you will be taking your steps. How can you recover? So on the basis of that, your economy bounces back from the recession, gradual increase in economic activities, and employment stabilizes and begins to grow. Sets the stage for next expansion. Again, the cycle goes. So your automobile sales during economic booms and recession, real estate market fluctuations, industrial production cycles are the examples of your cyclical components. So your business significance, it helps organizations prepare for economic downturns and growth opportunities. So you should be, or if you are a business organization, then you should be prepared for all these things. Next is your random component. Random variation presents irregular, unpredictable fluctuations that cannot be explained by trend, seasonal, or cyclical factors. Maybe it causes due to your natural disasters, pandemics, wars, political events, certain market shocks, and so on and so forth. Now you might be noticing certain things that due to your Middle East war, your all energy articles are having a fluctuating market, and that is your random, and it is due to war. So COVID-19 impact on airline traffic, supply chain disruptions, unexpected policy changes, and so on. So highlights this significance, highlights uncertainty and risk in forecasting. So during this period, you can't do many things. So why understanding components is matters? By separating time series into components, a manager can identify long-term trends, measure seasonal demand patterns, understand business cycle effects, improve forecasting accuracy, and develop better strategic and operational plans. So every time series is a combination of all these four components, that is trend, seasonal, cyclical, and random influences. Understanding these components is a foundation of effective forecasting and business planning. Suppose say a question is sales of air conditioners increase every summer and overall sales have been rising for the last 5 years. Which components of the time series are present? You may say your trend and seasonal variations. So, for making the analysis, we have to decompose these methods in time series analysis. Decomposition methods in time series analysis, that is, we will be separating time series into meaningful components. So the decomposition method is a technique used to break down a time series into its individual components so that each pattern can be studied separately. Okay, by decomposing means we will be segregating each of the component in our time series. To identify the major trend, seasonal variation, cyclical variation, and random variation. This helps managers understand and underline the underlying structure of the data and improve forecasting accuracy. So the time series is viewed as a combination of several components, and multiplicative model of our time series is this: yt is equal to tt into st s into c into r. So where y is your observed value, t is the trend component, s is the seasonal component, c is the cyclical component, and r is the random component, and the t indicates that it is over a time interval of t. Similarly, our additive model is y is equal to t plus s plus c plus r. So these are used when your seasonal fluctuations remain approximately constant over time. Okay. So why use decomposition? To identify long-term growth trends, measure seasonal demand patterns, understand business cycles, improve forecasting accuracy, plan inventory and production, and support your budgeting and resource allocation. So how can we decompose, or how can we make our decomposition analysis? Steps involved are: step 1, observe data. Start with your raw time series data, maybe monthly sales or daily temperature readings, etc. This is actual recorded values over time, that is your YT. So compute your moving average. What is that? We will be just covering next. So smooth out short-term fluctuations by calculating moving average. This helps reveal the underlying pattern by averaging values over a defined window, maybe 3 months, maybe 12 months moving average, maybe any time period, maybe some years. Depending upon your data, you can decide that. So estimate the trend, identify the long-term direction of the data, upward, downward, or stable. The trend represents the general tendency over an extended period. So this measure, step 4 is measure seasonal effects, detect regular repeating patterns within the fixed periods, yearly, quarterly, monthly. For example, higher ice cream sales every summer, increased retail sales every December. So seasonal component is S. Then fifth one is step 5 is estimate your cyclical effect, long-term fluctuations, identify long-term fluctuations that are not fixed in the calendar period. Unlike seasonality, cycles can vary in length. So cyclical component is CT. Isolate random variation. What remains after removing trend, seasonality and cyclical component is your random noise, irregular or residual component. So random component is RT, or you may say epsilon T. So then forecast the values, reassemble the decomposed components to predict your future observations. So your classic additive decomposition model is this, and multiplication model is this. So decomposition, observe the time series, the steps are being pictorially represented for your better, what you may say, my mental memory. So this is observed series is equal to trend, seasonality, cycles, and random irregular. Okay, so observed time series, actual data collected, long-term upward or downward, regular predictable fluctuations, long-term cyclical fluctuations, and irregular or unpredictable fluctuation. So a time series is again, key idea we know is a time series is a for the combination of these four components, and by decomposing the series we can understand its behavior better and build accurate forecasts. Summarizing, the workflow follows the classical time series decomposition approach. Take the raw data into its underlying components, analyzing each separately, then recombine them to generate informed forecasts. It's widely used in fields like economics, finance, weather forecasting, and inventory demand planning. So, taking one numerical data, we will be studying exactly how can we do that. So, historical data cells, say quarterly cells of an engineering firm, and the figures are rupees in lakhs. We have recorded the 4 years data of 4 quarters in each year. So sales are increasing every year. You may say Q3, that is third quarter data, consistently records high sales in comparison to others. It indicates both trend and seasonality. So average annual sales in each year, if we will be calculating, then it is coming around this. I hope you can know how can we calculate it. It is 50 plus 60 plus 75 plus 65 divided by 4. That's all for each year. Then annual average sales, if we will be calculate, is trending from 62.5 to 80.75. So growth indicates a strong positive trend. Then overall average sales, that is overall, if we will be calculating all the 4 years, then overall average is 70.38. So average sales by quarter is this. Okay, so the seasonal index can be calculated how? The quarterly average divided by overall average into 100. Okay, so by taking that into consideration, we have calculated our seasonal index for each quarter as this: quarter average divided by overall average into 100. Suppose say over here quarter average is 58.25 divided by 70.38 into 100. Okay, that is this. And for the quarter 2 and quarter 3 and quarter 4 accordingly. So interpretation of this particular calculation says that your quarter 1 sales are about 17.2% below average, whereas quarter 2 sales are close to average, and sales quarter 3 sales are about 20%, 20.1% above average, and sales are about 3.7% above average. Okay, so step 4 is develop trend equation, and step 5 is that forecast your future quarters. So assume least square trend y is equal to 62 plus 1.2 t, where y is your trend sales and t is your quarter number. So forecast for quarter 1 of 2025 is t is equal to 17 and trend, okay, is 62 plus 1.2 into 17, that is 82.4. This is how we do forecasting by using our decomposition. So by applying the seasonal adjustment, your seasonal index for quarter 1 is 0.828. So forecast is 82.4 into 0.828, that is 68.23. So forecast sales for quarter 1 is of 2025 is this. So what does this analysis reveal? Sales exhibit a clear upward trend. Managerial interpretation of the previous example is that sales are exhibiting a clear upward trend. Quarter 3 is the strongest quarter every year. The seasonal index is above 20%, and seasonal effects significantly influence performance, and your future sales forecast should incorporate both trend and seasonality. So your decomposition analysis separates a time series into trend and seasonal components, allowing managers to understand the underlying pattern and generate more accurate forecasts than using raw data alone. Okay, so next is by using the moving average method, how can we perform the time series analysis? So what is a moving average method? Is one of the simplest techniques used in time series analysis to identify the underlying trend by smoothing short-term fluctuations. Okay. So definition, what is exactly a moving average? Moving average is the average of a fixed number of consecutive observations, calculated continuously as new observation become available. Okay. Basic idea of using this particular method is that instead of focusing on individual observations, we analyze the average behavior of the pattern over a period of time. Okay. So why use moving average? Business data often contain random fluctuations, seasonal variations, and irregular movements. In the previous example, or you may say in the previous analysis, we have separated two components, one is trend and seasonal. But we didn't consider about random fluctuations and the cyclical. So over here, we will be the often contain, you may say your data often contain these three components. So your moving average helps you in smoothing out your fluctuations, reveal underlying trends, improve forecast accuracy. Okay, forecasting accuracy. For example, your 3-month moving average we will consider. So we have suppose we have the data about 3 months, January, February and March, and the data of our sales may be 100, 120 and 110. So your January 100, February 120 and March 110. So the calculation is marked down is equal to 100 plus 120 plus 110 by 3. So the new sum of 3 months is 330 divided by 3, that is we consider as your markdown, and the result is 1110. So forecast is based on the average of the last 3 observations. Okay, so the oldest observation is dropped. Why it is called as the moving? That is, oldest observation is dropped, the new observation is added, average is calculated. So when we will be considering the next, suppose say January, February, March, then again February, March, April, and then again March, April and May. So we will be, each time we will be dropping the oldest observation. So new observation is added, average is recalculated, and average window moves through time. So accordingly it moves. So for an n period moving average, it will be x1 plus x2 plus x3 and so on into xn by n. So moving average, MA is moving average, x is the observation and n is the number of periods. So suppose say this is my data, so monthly sales data over 6 months. So calculate 3 months moving average. So for April, my moving average will be 110. Okay. For May, my moving average will be 110, 120 plus 110 plus 130. 100, 120, 110. Then 120, 110, 130. Then 110, 130, 140, then 130, 140, 150. Okay. For April, my this is this 3 by 3. So for May, the other 3 by 3 and so on. Then, okay. So 100, 20, 30, this, then 120, 110, 130, 120, then 130, 140, 150, it is 126.67. That is 3 months moving average. So visual pattern observation is actual sales fluctuate month to month. Moving average provides a smoother series. Underlying upward trend becomes more visible. Over here, the data trend is not that visible, but when we are calculating a 3 months moving average, this data shows a clear upward trend of our sales. So, types of moving average, simple moving average, all observations receive equal weight. 100, 120, 110, we are not taking another as such. Weighted moving average, recent observation receives greater weight. Okay. The weights will be 1, 2, 3 and so on. So the choosing the number of periods, small moving average, it is 3 months, more responsive, captures recent changes, more fluctuations. Whereas in case of weighted, your large moving average, that is we calculate the 12 months and so on. And smoother trend, less random variation and slower response. The more your period, number of periods is more, in that case the trend will be more smoother, your fluctuations will be less. Then advantages of moving average, it is easy to understand, easy to calculate, smooths your random fluctuations, identifies underlying trends, useful for short-term forecasting. It is useful for short-term as well as long-term. Limitations of your moving average is it basically lags behind the actual trend. It cannot quickly detect the turning point. Less effective for strong seasonality, as because we are smoothing basing on our moving average, so it will not be able to give you that visualization for your strong seasonality factor. So it gives equal importance to all observations. The business applications wherein we use this method is in case of marketing, while forecasting our sales in our retail industry for our sales trend and sales analysis, and demand planning during our manufacturing, inventory planning, inventory scheduling, etc., production scheduling, supply chain, inventory management, finance, and revenue forecasting. So managerial applications, interpretation of this particular method is that suppose a retail chain observes actual monthly sales fluctuate considerably, moving average slows steady upward trend. Okay, the fluctuations can be smoothened. So managerial action is increase inventory sales, expand production capacity, plan your future marketing campaigns, forecast future demand more confidently. So key takeaways from your moving average is that it is a simple yet powerful forecasting tool that smooths your short-term fluctuations, reveals long-term trends, and provides managers with valuable insights for planning and decision making. So next is autocorrelation. The correlation between a variable and its own past values. Autocorrelation in a specific time intervals. Okay, in a specific series. Earlier, we have considered the correlation as the association between two variables. That is specific relationship between two variables. But over here, in the same series, we are trying to find out the correlation between the variable, present value and its own past value. Okay, so it is rho k is equal to correlation of xt and xt minus k, where k is the lag. So meaning measures memory of a time series. So what does your autocorrelation tells us? Basically, your autocorrelation measures the relationship between a variable and its own past values. It indicates how strongly the current observations are influenced by previous observations. The formula for calculating your autocorrelation is rho k is equal to xt and xtk, correlation between. So xt is current observation, xt minus k is observation at lag k. So autocorrelation, rho k is autocorrelation coefficients. So the range of autocorrelation coefficient is between -1 and +1. If your value is calculated as +1, then it is perfect positive autocorrelation. If it is between plus 0.7 and 0.99, then it is strong positive. And if it is between 0.0 plus 0.03 and positive 0.69, then it is moderate positive autocorrelation. And if it is 0, or no autocorrelation, and if it is between minus 0.3 to minus 0.69, moderate negative autocorrelation, and minus 0.7 to minus 0.99, strong negative, and if it is -1, then perfect negative. So positive autocorrelation means high values trend to be followed by high values, and low value trends to be followed by low values. And negative autocorrelation meaning high values trend to be followed by low values trend to be followed by high values. And zero autocorrelation means current values are unrelated to previous values. So characteristics of your autocorrelation is that it is completely a random movement, no predictable pattern, and past values provide little forecasting information. Managerial interpretation is autocorrelation is high. If autocorrelation is high, then manager can forecast future demand with greater confidence, plan production schedules effectively, optimize inventory levels, and improve budgetary accuracy. And if your autocorrelation is low, then managers should causal forecasting models, include external variables, monitor environmental changes closely. And if autocorrelation shows seasonality, manager can prepare a seasonal demand peaks, schedule manpower requirements, plan promotional campaigns, manage inventory proactively. And if it is negative, meaning high values, low values followed by high values, zero means current values are unrelated, characteristics is completely random component. So practical examples, maybe autocorrelation measures the memory of a time series. The stronger the autocorrelation, the more useful historical data become for forecasting future values. So rule of thumb is high positive autocorrelation function is trend and predictable, seasonal peaks, seasonality present, oscillating, cyclical behavior, near zero ACF means random series. So for managers, autocorrelation is a diagnostic tool that reveals whether past data can be trusted to forecast the future. Okay. So stationary, mean remains constant, variance remains constant, non-stationary series means mean changes over time, and trend exists. So your GDP series is non-stationary, daily temperature is stationary. So next is your Marx Jenkins model. It is a modern approach for your time series forecasting. So your Box Jenkins methodology develops. It is developed by your George Box and William Jenkins during the year 1970. Is one of the most widely used approaches for analyzing and forecasting your time series data. So basic objective of it is to develop a mathematical model that captures the underlying structure of a time series and generates accurate forecasts. Okay. So key idea is that let the data speaks for themselves. Unlike regression models, your Box Jenkins models primarily use historical values of the variable itself. So your why Box Jenkins? Traditional forecasting methods such as your moving average and exponential smoothing work well for simple patterns. But whenever your business data often exhibit trend, seasonality, serial dependence, random fluctuations, so your Box Jenkins can effectively handle these complexities. So fundamental assumptions is that stationarity and non-stationary. Before applying Box Jenkins model, the time series should be approximately stationary. Okay, a series whose mean remains constant and variance remains constant is called as your stationary series. So your correlation structure remains stable over time for a stationary series. So daily temperature deviations from average. So components of your Box Jenkins model are AR, MA, ARMA and ARIMA. So where AR means your autoregressive model current value depends on previous values of the same series that we have just discussed. Okay, and it can be represented as xt is equal to small c plus phi xt minus 1 plus epsilon t, wherein your xt is the current value, xt minus 1 is the previous value, and phi is the autoregressive coefficient, and epsilon t is the random error. So interpretation of this is that today's cells depends partly on yesterday's cells, and application is that in demand forecasting, sales forecasting, and economic indicators. So the Box Jenkins model, autoregressive, moving average, autoregressive moving average, and autoregressive integrated moving average. Okay, AR is autoregressive, MA moving average, ARMA the combination of both, and IMA one more is that is autoregressive integrated moving average. Okay, methodology of Box Jenkins is identify the order of the model, then estimate the parameters of the chosen model, and then check whether the model is adequate, residual, be it like white noise, then forecasting and key insights. So moving average we have already discussed. Autoregressive moving average is AR plus MA. It is the combination of both autoregressive plus moving average. And autoregressive integrated moving average is AR order, autoregressive order, differencing order, and moving average order. So ARIMA combines autoregression, differencing, and moving average. So key takeaways of your takeaways of your time series analysis is that it converts your historical data into future insights. So what we have learned so far is that your time series analysis examines data collected over time to identify patterns and forecast future values. And every time series consists of 4 major components. One is your trend, which speaks about the long-term movement and short-term movement, the upward movement and downward movement of your data. And the second one is your seasonal component, the regular or repetitive occurring or regular recurring patterns during some specific time periods, and cyclical is during your business fluctuations, and random component is unpredictable variations during extraordinary times, like maybe your war, maybe your natural calamities, maybe some famine situation, and so on and so forth. And how can we make the analysis? And we will be decomposing each of our components separately to have a better understanding of the underlying patterns, and we have done that with specific decomposition analysis by separating these components to better understand our online patterns. And one of the model we studied is your moving average to smooth our short-term fluctuations and reveal long-term trends. And then we have discussed about autocorrelation, which measures the relationship between current and past observations. It helps in identifying your persistence, trend, and seasonality. And one more is our Box-Jenkins model, which is basically a family of time series models for forecasting. The basic goal of it is to model the pattern in time series data and forecast future values accurately. And your Box-Jenkins model family, it consists of 4 components. One is autoregressive, one is moving average, one is autoregressive moving average, and one more is autoregressive integrated moving average. Okay, and your autoregressive, it uses past values of the series to predict the current value. The notation is ARP, where P is the number of autoregressive terms. And your moving average, it uses past forecast errors to predict the current value. The notation is MAQ, where Q is the number of moving average terms. Maybe 3 monthly, maybe yearly, maybe 6 months, and so on. And one more component is your autoregressive moving average that combines your autoregression and moving average components. The notation is ARMA, PQ. P is your AR term and MA is your, Q is your MA terms. Whereas your autoregressive integrated moving average, this is ARMA model applied after differencing to make the series stationary. Okay, so notation is ARIMA, and this has 3 parameters, P, D, and Q. P is your autoregressive term, D is your order of differencing, and Q is your MA term, moving average terms. So your AR captures persistence, and that is autoregression captures persistence, moving average captures shocks, and ARMA, that is autoregressive moving average, combines both, whereas your autoregressive integrated moving average adds differencing for non-stationary data. So your methodology, how we carry out this is that we will be identification. First, number 1 step is your identification, that is identify the order of the model using your plots. Then estimate the parameters of the chosen model. Then third one is diagnostic checking, that is check whether the model is adequate, residual behavior like white noise. And the fourth one is based on your this thing, use the final model to forecast your future values. So these models help uncover your structure in data and generate reliable forecasts. So this is the latest model in making the analysis and performing the accurate forecasting in your business performance. Then so your Box-Jenkins model we have studied and provides sophisticated forecasting techniques widely used in business and economics. Then basic key takeaways from this analysis is that time series analysis enables managers to transform historical data into actionable forecasts, reducing uncertainty and supporting informed decision making in a dynamic business environment. And your time series analysis from historical data to strategic decisions and highlights over here are we understood what exactly is time series data, trends, seasonal, cyclical, and random components, decomposition analysis, moving average methods, auto-correlation analysis, Box-Jenkins models, and business forecasting applications. So key learnings from this particular unit is that the future may be uncertain, but patterns are hidden in historical data, provide valuable guidance for making informed managerial decisions. And for managers, forecasting is not about predicting the future perfectly, but it is about reducing uncertainty and improving the quality of the decision. And the best way to prepare for the future is to understand the patterns of the past. So in this particular world of overflowing with data, the ability to analyze, interpret, and make informed decision is one of the most valuable managerial skills. So your learning never ends, though this course has concluded today, but your journey of analytical thinking, problem solving, and data-driven decision making has only just begun. And because you have learned the things, you will start doing the things. So wishing you all every success in your academic, professional, and leadership journey. Stay curious, stay analytical, stay innovative. Thank you, and all the best.